Hi, Dravin.
Okay, so yeah, what? Let's start with Ram. If you have any questions for me.
Uh, yeah, the Merkle tree part, we had a discussion with David in the morning.
Hmm.
Like the approach that we thought was in the sense like we were trying to create everything in the solidity contract. So the confusion was if everything was done in the contract,
Hmm.
how do you produce proofs and all? But later. When we discussed with David, he said now the proofs everything has to be sent by the client. Then will be matched with the root hash that is stored in the contract.
Hmm.
So after that, we were clear like okay, the client has to send the proof and then the hash, and then later the Merkle verify will verify both of them with the root. So that was the confusion was if Merkle, when using Merkle trees, right? So any change in the leaf will affect the root, right? Thinking like now everything is put into the solidity contract,
Hmm.
then any changes onto the this thing, the leaves, a new leaf is added, then the root modified or updated.
Hmm.
So how the client know is proof and all, but later then we because all the white addresses are also with the client, so the client generates the Merkle proofs everything, and then you verify against the contract. So
Yeah,
that's clear after that.
yeah. I think your question is more from like the application point of view. So
Yeah, more application point of view.
how the end user are gonna do that?
Yes, that's
So
correct.
yeah, maybe you already have an idea. So I can just go something on top of it. So this is a very Merkle airdrop um, project. It's a very simple.
Mhm.
Yeah, you can just go here. I think so. This is logger
Uh,
data. So config data is going to have all the airdrop stuff,
okay.
and then it is going to start generating the airdrop here. What it will, for example, airdrop means you will be getting right
Hmm.
against your address. So your question will be like how this addresses and everything are collected. So say for example, I created a right. I
Mhm.
created a swapping contract. Then I decided as a project, as a project founder, that whoever will be interacting with my swapping contract, depending on value they have swapped equity, I'm going to give them airdrops, right?
Right.
So I'm going to collect all that data. So of course, if you are going to do a swap, there will be events that will get emitted from the contract, right?
Mhm.
So I'm going to collect all that events, and from there I'll get to know their addresses.
Right.
And then once I have their addresses, I will also get to know that how much amount equivalent in USDC. By doing scripting, I
Yeah.
collect the equivalent USD value, and based on that, I will create a data, right?
Mhm.
And once that data is created, it will be in of key value pair, like at how much tokens I will be giving it to them, right?
Yeah.
So that's what he's doing here. Generator. Once the generator is created with decimals and airdrop,
Mhm.
yeah, it is going to process. So when you are processing, what it does is it will just creating a Merkle tree. You know how the Merkle tree works. You
Yeah.
have the diff all the way at the bottom, and then it is going to start taking the pairs, hash it up, and then if there were like four addresses, then at level 2 will get two hashes, right?
Yeah.
Level 3 you will get just one hash, which you call the root hash, right?
Right.
So all the things gets generated, and then they are writing it to the Merkle.json, right?
Mm.
So Merkle.json file will be created somewhere, here maybe. And what happens next is, now you want, users to start using,
Claiming them, yeah.
yeah, you claiming. So what can happen is, if I just go to if you just go to the inspect window, maybe you should be able to JSON file. I'm not sure if you're able to see the JSON. Maybe you might not be
No,
able.
no, no, I can't see them.
Yeah. So let me share my whole screen. Window. Yeah.
Yeah, yeah, I can see that.
Yeah. So on, how much minification they have done
Mm.
while deploying. Should be in static. Chunks, pages, yes. Anyway, thrown it up and then look for, Merkle.
Yeah, yeah, I will look into this problem.
Mm,
Output path.
yeah, it's not there here. But anyway, if you go to pages, claim, loading errors while we collect details about it. Data loading. You, it will create a hash for address. Get container. Airdrop amount. So the airdrop amount from the config. Uh, so there will be config here. We can see this is a sample, details. So like,
Okay.
and if this is my address, then what will happen here token. So it will just collect it will just look
Addresses.
for my address, and then this way we'll be able to get the airdrop amount. Um, claim airdrop. So is already there, and then about the route already
In the
stored.
contract, yes,
So
stored
whoever
in.
will be deploying, like, they can just pass it. They
Yeah,
can
yeah.
pass the route in the constructor, and it can happen. More users who are getting added, then you can just add a setter.
Yeah, yeah, we did the setter part.
Hmm.
So whenever there is a new update on the route, we use the update setter to update.
Hmm.
But
So
the
there,
query was the intent part. But now I think, yeah, this I got it.
yeah, I'll just finish it up so
Sure.
that others can also manage. Um, so yeah, so this way you'll be able to get the route. All you need is just a route, and then there is another thing. You also need proof. To it should be there as a part of, yeah. So proof is also which you have to pass. Now this is something which user does not have to like carry. Like, if I'm the front end user, I don't have to carry the proof. It will be there inside the front end. You can just hard code it. Now this might not be there, but when we generated Merkle.json, that details will be there in that file,
Hmm.
Merkle.json. So after you check the claim status, the next thing is, we will have to pass proof, right? So there are two ways. Like, what I used to do is, I used to have the um, I used to do the proofs inside the file, so the front end does not have to the proof. Okay. Uh, yeah, I'm not sure if I have that. I have it public repo or not, but I shouldn't show it. But anyway, the fact is, like, there are two ways. One of the way is you can generate proof in real time, the one this method that you do, and another way is you can just have a static JSON file where proofs each addresses are being stored. Okay, both ways are just fine. I think it's not a big computation. um so this way we are getting the proof. In order to get the proof, you should be having like the whole list of addresses and corresponding amount. Then only you'll be able to generate a proof, and then that proof is passed here, right? And then you can claim. Okay, so this is one of Merkle tree. Do you know how many Merkle trees do we have in blockchain, like in Ethereum to be specific?
So I was thinking Merkle tree as does it
Yeah,
have types in it?
multiple trees
Okay.
in Ethereum. Um, so this is a very classic interview question. So if you go to a block, right?
Yeah.
Um, this is the block hash. Okay,
Right.
this is the state root.
Mm.
You have got the transactions root as well, and then so till byte of the block, root hash of the whole blockchain, and
Right.
up till block. Whatever the hash comes out, that is going to be the root that particular blockchain,
Okay.
and this is the state root hash. So what is a state? Whenever you are making a transaction, there are multiple state changes that happens. Okay. For example, if I can just yeah, just have a look here. So balance, right? This is a very classic state change that happens.
Mm.
You have to pay the gas, right? So so this is like so there are two addresses that gets in which you see the change. So this is an MEV transaction which paid this guy. So you see that this address a balance got increased, right? So this is a for transaction. You can just take it that way, and then the non-increase for the sender. So this guy sender, this is a receiver.
Yeah.
This is the stage. Now there are multiple transactions and multiple state changes can happen. So if you want to get if you want to build a Merkle tree for that, this is what the root hash comes out to be at
Okay.
this point. Okay. Another is the transaction receipt. Okay. This basically is the hash of the transactions. Okay.
Yeah.
And then we have got the
So within a block.
within a block. Yeah.
Okay.
This is transaction like Merkle tree root for the transaction receipt.
Right. Okay.
Okay, this is for withdrawal.
Withdraw.
What is withdrawal? Okay, so right off stake, um, you get a reward by if you are a validator, then you will be receiving the reward. Now those rewards are also added as a part of the block. So every time a new block gets added, if a payout needs to be released from chain, then the beacon chain is going to interact with the execution layer, and execution layer I will be also adding. There are 16 withdraw, and 16 can be accommodated. That is what is the ETH 2.0 is,
Mm.
right? So you can see all these rewards from the beacon chain are added here. So all this data is also Merkle tree, and the withdrawals route shows that basically, right? And we have got the transactions. So this also is there as a part of this is also Merkle tree data structure. And there was a very good article written by Vitalik, which is a very old article and also outdated. It is outdated because it does not include the withdrawals route. So every
Okay.
block header in Ethereum three kind transaction receipts and transactions receipts and state are actually three trees, and then there is fourth tree root. But this article was written in 2015, so the proof of stake back in time. So it just
Right.
misses those detail. So like if you were my student before 2020, then I would have just said there are three Merkle trees, but,
Three Merkle.
right now there are four. So your reference, you can have this handy with you, because
Yeah,
if you're still having current information, maybe incomplete information is fine, but information is not incorrect, it might be.
incorrect. Yeah, yeah.
uh,
Very good article. Yeah, I'll go through this.
yeah. So yeah, you will get to know the proof of blockchain was started. We have Genesis, like, which is taken from genesis.config, like which had be given how much balance. So yeah, and this is Markups in Bitcoin. So it's yeah. So basically, the most used way, um, I mean, the most used application for Merkle tree is airdrops.
Yeah, that's okay.
Yeah, mostly people airdrops
So
only.
one in Dhruvin. So in when I was going through the videos regarding the Merkle trees, right?
Yeah.
So the in the video mentioning about like major softwares Merkle tree features. Like yeah,
Hmm.
uh, it was because okay they might it is a better way to handle most of the
Hmm.
but he what he mentioned was like the roots rehashed every time. So I when I keep adding data,
Hmm.
so the roots get rehashed, right?
Yeah.
So
Yeah.
query is like now every time a root like in terms of databases you keep adding data every time, right? Update a particular column or a key. So how does that system handle so much of writes IO activity? Because every time you change data, everything is getting refreshed. Is my understanding correct or is something?
Yeah, I think you have got a valid point, and it is just of an time Merkle tree performance. So you are asking about the speed, right?
Yes, now because if the root is attached to every detail of the records in the database, so now any let's say a table itself, right? So a table has got and grow to million records. So it has to remain constant. Only the
So
added data
yeah,
should
if we talk about the client software, for example, Go Ethereum,
yeah.
then it's always the database file is always on the same system. So
Right.
the read, yeah, so it is not recommended that you have the database, uh, hosted on a separate machine, like as blockchain goes.
Mhm.
You cannot have it in the separate machine. So yeah, about one tier architecture, two tier architecture,
Yeah, yeah,
three
yeah.
tier architecture. Yeah.
Yeah.
So blockchain is a two tier architecture, right?
Okay, okay.
So you got the application layer
The
and the DB
client
layer.
and then the middle. Not
Client
there will
is
not be
in a
middleware
separate
then.
machine, yeah, separate machine, but your application layer and database layer needs to be on the same machine.
Yeah. Okay.
However, Blockchain software, we call it as a client. We never call it as a server. The reason
So,
that software acts both as a client because it also right talk with other peers. It has to give responses from the request made by other peers. So we call it as clients actually.
right.
But yeah, but if you want to just put it in simple words, then yeah, it's server and database, like application and database are on one machine, and then client can be on a client is like your front end with it, right? Yeah. And then actually in blockchain we use Merkle Patricia. It is a little bit improved version of the Merkle tree, but yeah, Merkle trees are faster. They are able to store the data in more compressed form, right? So that's the reason we can also do parallelism in Merkle tree. Um, so, but if you want to see the performance, yeah, of course, like you will have to go and just the speed Merkle root calculation by O of n notation.
Okay, okay.
Hmm. Can definitely get that from the NAS. It's very handy article. Another use case of Merkle is in vesting schedule. Do you know what vesting schedule is?
No, no, I don't know.
Yeah, like this is when you are going to join any organization, um, like any blockchain who have got crypto. So this is layer zero. Do you know? Do you know? Have you heard of layer zero?
Layer zero, no.
Okay. So
Is Ethereum, right?
layer zero is actually in a company
Come.
startup. So layer is into cross chain infrastructure. Okay, we are say layer zero is cross chain, which means that if you want to pass message from one chain to another, then they are having a middleware for that.
Okay,
You can pass. So all you have to do is just event in whatever format that they have specified.
okay,
You can docs, and then you need another contracts in okay, which is going to call a function on a specified so if you do that way, so basically what happens is they have event listener in between. So it is going to listen to an event from chain one, and then it will relay the message chain two, like that. So I have built that very granular, a very efficient level, and they are hosting those middleware in their own infrastructure. They also partnered like Google Cloud Services. It's a very high level, not I wouldn't say high level, but it's a very scale project, and build certain standards for they call it as DV. It's also it is um, peer to peer. Like it's not just a centralized server, but their off-chain infrastructure is also peer to peer. They're trying to make it decentralized. If tomorrow, if you want to become the part of their network, then you can also run your own node,
mm,
basically. Okay. Okay. So, example, tomorrow, if you will be getting a job in zero, so what they do is equity, like company give equity,
yeah,
yeah, shares. But they don't give you like right away. What they're gonna do? Once you start working for them, and if you stay them for an year, then they will be releasing the shares after that period of time, and which means that if you were promised to get if you were promised to receive like 1,000 shares over a period of 1 year, you're not gonna get all the 1,000 shares at once. You will be getting in a linear vesting period, in a linear vesting style, right?
yeah.
So you can do that using this contract call. So this is what this is where things gonna happen about the vesting stuff.
Okay.
Redeem with proof. root. Yeah, so you are you will be on this tree. Your address and with your address will be the value, and then you can redeem with the proof here. So
Okay.
you are the user, just give proof.
Oof, yeah.
If it is part of the tree, then statement will be true, and then you will be able to redeem
Redeem it. Yeah.
the amount whichever you were supposed to, based on the linear vested. That's the one. Also check amount is redeemable right now. So that is also another.
Okay. Okay. Got it. So, Dravin, how do we have a or some information have where find such contracts?
Merkle tree. Yeah, this
Not
is.
not 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 Merkle. You're showing me one of these, right?
Hmm.
So how do we know? How do we search, scan for such?
No, you cannot. Actually, I had because I attended some
Okay,
seminar or something like that, and no, you
okay,
will not be able to find it. Yeah, you just bookmark like that.
okay,
So I have like a whole library which I keep on updating. That's it. If you so this is like this is one of the way for creating the vesting schedule contract.
yeah,
There is another way as well. I actually my client and it's open source, so I'll be able to show you that it's a token vesting. So this is using the Merkle tree, right?
okay,
I'm not using Merkle tree here, and works is you can just create a vesting schedule. So, for example, a new employee got added to your organization, and then you want and like when you join a company, you will start on one of the the company admin is going to get you an email ID, right?
yeah, yeah,
I want to create an account for you in accounting system so that you can generate a pay stubs for you, transfer currencies into your account, etc. So in crypto, this is one of the way of it.
okay,
Company admin is going to come. They're going to add you as a beneficiary. They're going to would like to start the vesting schedule. Then
mm,
up till what 2 year, whether it is revocable. Revocable means your vesting schedule can be revoked if you leave in between. So it's
yeah,
up to the admin and whatever terms you agreed on. And then the amount, how much amount you want to receive over a period of month duration. So it gets created, and then you can come and just say release. So it's going to release the money, right? So you just have to provide your West schedule ID, which will get created when uh, you know when you create the vesting schedule. This vesting schedule ID is something that you will that could be your employee ID as well, right?
yeah,
But in here we just what we do is we do a kitchuck 256 hash of the battery along with the index, right?
mm,
And that is gonna get you the ID. So you can also calculate in as well. The provided you have your addresses like your name on blockchain, and this is a calculation for that, right?
yeah,
And yeah, you can then just deploy. So this is a repository, in which I have included the front end as well as you will also be seeing
all that, yeah,
hardhead.js and next.js. So you use this as so this is a vesting application.
okay,
The Etherscan link which I showed you is also vesting app, but
okay, okay, yeah, okay,
it is using Merkle tree is without using Merkle tree, right?
yeah,
So there are variants in that, and also connected with as well, and then Versal app as well. So you can connect it and you can do real time deployments. I have it deployed on Binance Chain because I did it for one of my and I did on the test net as well. So for testing
Okay.
and then local. So this is a complete, production ready boilerplate, which you can use for any other uh, utilities as well, right?
Yeah, yeah. This will help us
Yeah, and
because I'm looking for projects where I can practice. I think this will help me a lot.
yeah, but just make sure that this is like 2 years older. So I haven't made any updates. So you might have to do some updates. If you go,
Yeah, yeah, yeah. The versions. Yeah,
you might have to update hard hat. Is not used. Maybe Ether's V5 now it's V6. 2.0 is the hard hat, so you might have to update that. So might break things. I don't know.
yeah, well, because that would be good. We can fix it.
Yeah, and then I have also included the test like for both.
Okay, sure.
I created a token sale and token vesting. There are two applications in it. Token sale ICO like the module one that you did,
Yeah, yeah, yeah.
but it's quite different, a bit different. Like, so the way it does the token sale is, instead of accepting Ether and Binance USD coin, right?
Mhm.
And then what it does is it does not give the token right away. It creates a vesting schedule. See, so
Mm.
if you get, then you will have to buy using whichever stable you have, and then a vesting schedule will be created. So now this contract actually calls this contract.
Okay. Right.
Okay,
Yeah,
and then as an admin, you are a client and monitor that what is the status of your sale. So what are you gonna do? You need what do you need? You need some dashboard. Yeah.
yeah.
So we also have dashboard as well. Token sale. This is for token sale. This is for, yeah, I don't remember, but I might. Uh, hmm, pages header.
Dhruvan, just give me a few minutes. I'll be back.
Yeah, so this is actually, so if you want to, what is a, you know, status of your sale. So it will fetch time. Once have been logged, how many of the users, have deposited. They read call, um, creating a vesting schedule on our own, right? What else? Fabrizio, Jake.
No, on my end, I am still going through the video of this week 4. So I looked like to the FOT unit testing.
Mhm.
So I think tomorrow I'll finish with the video and I will start with assignment for this week. I saw we also need to make like 3 Ethernaut challenges. I hope they won't be too hard.
Ethernet are not that hard. Just forget.
Yeah.
Okay.
Okay.
Yeah. What about you, Jake?
I'm still just catching up right now.
Do you guys got a chance? Blockchain UI.
Yes, I think yes. Remember when, but
You might have
like
watched a video, maybe.
yeah, maybe yes. Like it explains like it works the blockchain at each step, right?
Yes.
I saw it. Yeah,
Hmm.
it was really helpful to understand each step.
Yeah.
How
Yeah.
yeah.
Yeah. So we were talking block hash. So hash is actually the hash of all this like any change. Even like if I remove the zero, it change in this hash. And if the hash gonna change, all that are going to get invalidated. You're downloading the blocks from a trusted node or not, right? So that's the one. Um, so what you'll have to do is like, well, if you want to still, do this, you have to mine like all the blocks, right? So, and if you want to do that, you need computing power than 51% of the entire network. So that's what you need to do if you want blockchain true. Making some changes in a DB, well, of 51% attack, basically.
Okay.
Yeah.
And it gets more difficult over time
Yeah,
as as more blocks.
yeah, the more longer the chain is, more genuine the is, so can then use that basically. Right, so if you want to add any data, like it changes the hash, so you'll have to mark it, so that so you can like each block needs lot,
Okay.
right?
So each block hash is bounded to the previous block's mind.
Yeah, so to create a hash, so that this nonce is achieved. This is a different nonce than transaction nonce. This is just like some random number that block and this number should be achieved when you are using this hash, right? So this is basically a proof of blockchain demo.
Okay.
Hmm.
Sake, like the Ethereum model.
Yeah, not the UI, but you can it up like locally.
Okay.
It was created by Off-Chain Labs. Yeah, so this is for the proof of stake if you want to create the things locally.
Awesome.
So it spins up the execution client, consensus client, and validator client. So you just need to run Docker compose up, and then it just spins it up.
Awesome. I'll definitely check this out. Thank you.
Whereas, also, if you don't want to spend time now on how to, because you are anyway going to adding across. Okay. Yeah. So I think there's. I don't want to. Uh. With some more information. So. Yeah. If you any other questions, you can drop off. I'll also drop off later on.
Okay. Thank you so much. Thank you. See you, Druvin. See you all. Bye.
Thanks. Have a good one, guys.